guess all of you are practically new to the space field. This might be one of the first lecture on the space engineering. We'll start with satellite technology, and then you'll be also exposed to rocket technology and also space technology. In fact, you will start space mechanics, then after that space launch. So in order to understand the whole relation between all the subjects, I think the most important subject to learn first is basically space systems. Now, space systems comprise of course, space technology first. So therefore, specifically in this lecture, you'll be exposed to space and satellite technology. Then you will see also the difference between an aircraft and a satellite. I think all of you have been very well exposed to aircraft. You know how aircraft flies, and you know how to design an aircraft. Now I think it is time for us to look into maybe a spacecraft. Start with a satellite to see how they can fly, what are the prices of the satellite, and what are the equipments important to keep them flying, and how to design that, and what are the difference between all these equipments, and how we can all put together these equipment so that they can fly. Now, more important is to look into the semester. Now, if you look at it, most of the semester that we have planned is practically going to be online courses. But I think it is important for me to be here, sort of face to face, so that you can actually understand a bit more compared to you are looking at me through the desktop. So that is very important for me to establish. If you look at it, we have about 14 weeks like any other subject. So in this space technology, you will be actually exposed to the whole satellite. So if you ask me now, if you cut a satellite, what would be inside a satellite? That's what is important. We will start off the lecture, the first lecture with spacecraft structure. Now, the definition of spacecraft is basically a craft which flies in space. It could be a satellite, it could be a probe, and so on. So, in this particular, I want to make it general so that you can put any craft into space. It should actually respect the structure requirements in space. So, you'll be exposed to that first. We will look into specifically satellite structures. We will start off with that, and that is the basic before we can actually start going into other fields. Now, as I always been telling, importantly, assume that you are going to fly a satellite. Assume it's a cubical, well, I would say structure. More important is that to get this cubical structure done first. Then you start actually putting all those equipment inside. Just like an aircraft, you get that body, fuselage ready. Then you start actually looking into all those components. So that's what we're doing here. So we get exposed to, of course, the satellite structure. Then we will see how different it is, all those satellite structure. Now, in this particular chapter, what is important is that all your subjects that you have taken, strand of material, you have probably been exposed to maybe finite element analysis and so on. So all this actually, whatever you have covered in first year, second year, comes to play. Dynamics, statics, etc., all comes into play here. So I may want to give you a bit on a revision to look into all those components, but we're not going to spend so much of time on evoking all those subjects that you have learned. Expect you go back and read up all those lectures that you have been exposed to before. Then goes to the second subsystem. Now, as I've mentioned correctly, subsystem I would say. So after when you have a shell already, then you start actually looking into all those systems inside. In this case, specifically we use a word called subsystems. So the first subsystem we're going to use, we're going to see is the power system itself. Power system is the basic. Why without power you can't actually do anything. So you can't fly. So that is a basic power system that you need to have compared to any other systems that you have in satellite. We will be looking into all those options that you have in space. How can you generate the power? You can't use fuel. You can't. If you have a car, you can drive into a petrol station and then you can pump petrol, but you can't do that in space. So what are the options that we have in order for us to keep flying? So there are few options that we have, and we will discuss the most typical option here. So once you have the power, then you can start designing all the other systems, or you can start putting in all the other systems. Second system, the important system that you have is the multi-crew system. Why this is actually important? Now, on one hand, you are going to generate the power. Now, you have to make sure that the thermal compartment of the satellite is also stable. It's also conducive for your power system to work. Remember, you are also flying at a very high altitude. So if you go out of the sun, you can imagine that very hot. So likewise, if you are flying up there, let's say you're facing the sun, it will be very, very hot. So under that extreme condition, thermal control is extremely important to keep all those equipments healthy within their operation limits, so to say. After that, we will cover also propulsion system. You have been exposed to propulsion system, especially in the aircraft propulsion system. We will look at the satellite propulsion system, see how propulsion systems are actually going to assist us in order for us to fly in space. So that is following subsystems. Then towards to the middle of your semester, you will be exposed to onboard equipments. Now this onboard equipments, there is a lot of actually equipments on board. So basically, you can look at the telecommunication equipment. You can look at even control equipment, attitude stabilization equipment, orbit stabilization equipment. All those equipment on board that you embark onto the satellite will be discussed in lengthy manner. And then we will also finish off the lecture by looking into how can we qualify all this kind of equipment, what kind of typical tests that actually we do when we build a small satellite, for example, or even a bigger satellite, what we want to actually do, and after that, what are the qualifications needed and testing needed in order for us to ensure that it can fly safely into space. So these are typically 14 weeks plan. Now, more importantly, I think we are going to use, as you know, we are going to use Ultra Blast. So all those lectures notes will be actually uploaded before your lecture time. So please respect that lecture slots and corresponding exercises will be also given accordingly. Now, more importantly, let us look at the evaluation. Attendance will be an online attendance. I can monitor who is logging in to read the lecture, who is logging in to download those lectures, and who is going to actually start downloading the exercises. So 5% is quite a lot of marks to watch. Exercises, now this typically you may want to actually have a group. We can form a group and do a group exercise. It can be a virtual group, but we need to work together. So therefore, I think a group exercise is important so that you can keep in touch with your friend. Then we have a test or projects, 20 plus 20. Let's see, it could be a take-home test, it could be an individual project. When time comes, I can actually evaluate the groups better. Then we can actually move accordingly. But in any case, there will be a 20% and 20% here, which leaves us about 60% of the total marks. So now, if you look at the final exam, we've also given about 40% final exam, just like all the other lectures. We will also see how it can be done. It could be face-to-face, it could be also online, but depending on the actual situation after the goes to the 14 weeks. Well, I wouldn't, how to say, I wouldn't recommend books, but I think there are a lot of books actually you can learn, or rather you can study satellite technology. But more importantly is that my notes, my lecture notes, I think it's quite comprehensive. It comes from very, very different sources. So therefore, I think if you keep keep yourself busy with the lecture notes and the exercise that you're going to do in class, I think you should be fine. In fact, you should be scoring, in fact, in your exams and your graduation. Well, I don't actually, I do encourage extra readings. You can read books, lifelong learning. You can always read any subject books for you to enhance your knowledge. But if you ask me, basically, for me to do well in the exam, you must go through all my lectures, lecture notes, lectures, and of course all the exercises. With that, probably I think you will have a general overview. Now, I'll be always available through even WhatsApp or even through email. So you should be able to contact me in view of any questions in that sense. Otherwise, we can always link to drop class. Thank you. Good luck.